applied problems with hyperbolas, as well as analyze them with either being at the center or the origin and find the asymptotes. That's the part that's going to be different compared to other conics. This is the only conic that has asymptotes. So remember, just as a basic thing, if you have like 1 over x minus 2, that's a rational function, and the asymptote would be at 2. This is 1 over x, and if we shift it over right 2, it would look like that. Vertical asymptote x equal 2. So yours are going to have slanted asymptotes, and so they're going to look like equations of lines. So recall that a hyperbola is formed by the plane that intersects two naps of inverted cones. They can help you learn where a lightning strike occurred based on where a person heard thunder. It could also be used to find where fireworks display occurred. A hyperbola is, like the definition is going to be like the others, except for it's a difference instead of a sum. It's the collection or locus of all the points, the difference of whose vertices form your 2 points. It's from 2 points called the foci is constant. Now on another one you had like a major and minor axis, and on this one it's called transverse and conjugate. So that's the difference. So they have different names for the same type thing. It consists of 2 separate curves called branches that are symmetric to the transverse axis, conjugate axis, and center. The 2 points of the intersection are the vertices. So let's look at it real quick. Remember, if you want to, you could just do relation, but if you're going to do your equation templates, you're going to see east and west and south and north. So the equation template has east, west, and south, north. So the east-west is x minus h squared over a squared minus y minus k squared over b squared equal 1. And the other one is y minus k squared over a squared minus x minus h squared over b squared equal 1. So these are slightly different than the ellipse ones. Remember, on the ellipse ones, your a squared was always underneath your x squared or y squared, whichever one it was opening towards, or whichever one was the largest. So if it was horizontal, I'm just going to say recall on ellipses, if it were x squared over a squared plus y squared over b squared equal 1, that one indicated it was horizontal. And if it were x squared over b squared, okay, and this is since a is greater than b, x squared over b squared plus y squared over a squared equal 1, this is vertical. So there are going to be some slight differences. Here what you're going to see is a squared is always first. So the variable a must always be first, and c is the biggest. And so also you're going to see your minus signs instead of plus signs. And there are equations for asymptotes also. So when we're talking about being at the origin with the transverse being along the x-axis, you're going to have your x squared over a squared minus y squared over b squared equal 1. C is biggest, so it's going to actually look like the Pythagorean theorem. X and a has to be first, and C is greater than a, so the foci are not between, they are within a branch. Like on the parabola, where it's like the focus. Okay. Your equation is symmetric to the x-axis, y-axis, which is the conjugate, and the origin. Now, when it's vertical, it has these formulas. Y and A must be listed first, and so forth. Analyze means find the center, the transverse axis, the vertices, the foci or foci, and asymptotes on some problems of the hyperbola and graph it. The easiest asymptotes go through the origin, like y equal plus or minus x, y equal plus or minus 2x, 10x, etc. But there are harder ones. There's no requirements regarding the relative sizes of A and B. Contrast this to the ellipse where A and B tells you which one is the major axis. And again, said it a few times, they have asymptotes. So to find your asymptotes, you use this formula, which is very important. It's plus and minus b over a. X. The diagonals have slopes b over a and negative b over a. Okay, so let me go to that page. You can also see it on your online textbook. Page 662. Okay, so this one, the blue part is the actual graph, but the imaginary dashed lines are the asymptotes, and the one with positive slope is b over a, and the with negative slope it's negative b over a. So it's almost like you can draw a rectangle with b as the length and a as the height. And then it would just be the opposite if it were up and down. So if it were up and down, it would look like that. Notice the transverse axis is horizontal if it opens sideways, and it'd be vertical, the y-axis. Okay. So regarding the asymptotes, if it's horizontal and if b is bigger than a, the graph is tall, and it could be skinny if a is much smaller. I mean, you'll see all those like as we actually do our problems. But I mean, there's all your formulas and stuff. Yeah, I have all the formulas listed. So this time we use A over B instead of B over A if it's vertical. Like if it's this and this, then we have A over B. But on the other one, this was B over A. Okay, so let's get into it. There are a few definition ones I just wanted to go over that I know are going to be quick, but I wanted you to compare the definitions. So if it's this definition with the distance to a fixed point equals its distance to a fixed line, that's talking about a focus and the directrix line. And so that's the parabola. And on this one, if it says sum of two fixed points is constant, that would be like the ellipse, which is kind of like a track. I'm not going to go through all the drawings because y'all have already covered this. Now this one, to get your intercepts, remember your y-intercept is when you let x equal 0. So you'd say y squared equal 49 plus 16 times 0 squared. So if y squared is 49, then y is plus and minus 7. And so that's your intercepts. Now, the x-intercept, so that would be like 0 plus and minus 7, which is what you have. The x-intercepts would be when you let y equal 0, and so that'd be 0 equal 49 plus 16 x squared. Let's graph that, see if it even has some. I don't want to do extra work if I don't have to. Remember that you could go to relation this way, or if you just hit add graph and hit delete, then you can pick relation. So if you have y squared equal 49 plus 16 x squared. Wow, it just did a little blip and then went away. That's weird. I've never seen that before. So let me use the equation template instead. On this one we have, well, that's even in a different form. Looks like the best approach was just, let x equal 0 and just solve it. Okay. So your hyperbola definition is the one with the difference. And you have another definition one, and the foci lie on the line called the transverse axis. Major is the one for ellipses. Directrix is used on parabolas. And conjugate would be the perpendicular to the foci on hyperbolas. Okay, so several like vocab type questions. Now on this one, they're telling you that the center is 2, 1. So there's your y-axis, and here's your 2, 1. If the center is 2, 1, and if a equal 3, then you're going to do 1 plus 3 and 1 minus 3. And then your y value would then be 4 or negative 2. Your x value would be 2. So you have your 2, negative 2, and 2, 4. So if it's up and down, it's sort of like a parabola, but it's two-sided, and it's usually wider than like just a regular x squared one. Now this one is another vertical one, and this time they tell you your center is at 3, 2, and your C is 4. And so the coordinates of the foci are 3, 2 plus 4, so 3, 6, and 3, 2 minus 4, so 3, negative 2. And so that's your points. Three, negative 2, and 3, 4. 6. 3, 6. Okay, so again, a few easy ones. Now on this one, they just want you to remember that this is a squared and this is b squared. The a is the square root of 9. Remember, a is always first. And then this one's the square root of 16. So that's second. And if it's like that with x squared minus, then it's going to be x, since you have x squared minus y squared. Now, if it were y squared minus x squared, then it'd be y axis. Okay, so now you actually get into a little bit of the harder problems. For your focus, they're telling you 0, 7. So that's 7 up. That's 0, 7. And this one's 0, negative 7. That's your focus. And then the vertex is at 0, negative 2. And it says the center's at the origin. So that means the other vertex is at 0, 2. The center was at 0, 0. And then Now it's going to be opening up. So we're going to use c squared equal a squared plus b squared. So you have 7 squared equal, let's see, 2 squared plus b squared. 49 equal 4 plus b squared. Subtract 4, 45 is b squared. And so that means b is plus and minus square root of 45. But remember, we just keep it as a squared and b squared. So because of the vertex, meant a is 2, so a squared is 4. And b squared is 45. And that would look like this one, and it's the y, because it's up and down. On this one, it's telling you c has got to be 6. It goes across the y equal negative x. This should be dashed. Let me redo that. And if that's the case, then you have positive x this way. So what that tells me is when you were doing your equation, let's see, is this one vertical or horizontal? Because remember, if it's horizontal, it'd be b over a, but if it's vertical, it's a over b. Let's see, your focus is 0, 6, and this one 0, negative 6. So it looks like it's going to open up and down like that. So you have your c squared equal a squared plus b squared, and if it's like that, then you have 6 squared equal 1 squared plus b squared, because I'm thinking 1 over 1. So I did correctly put the b over a and the a over b. And this is the y-axis, by the way, because we said it was vertical. But we don't start with this because it wasn't that a is 1, it was that we need that the ratio is 1. So you have the same number for a and b. So you start with your c squared equal a squared plus b squared. If you use view an example, it's going to have you do b squared equals c squared minus a squared. And then they do a substitution since a equal b. And then you get 2a squared, and so then you basically take half of your c squared. So 36 over 2 is 18. That's fine. My way is more like c squared equal a squared plus b squared, and then just say a squared plus a squared is 2a squared, and then you get the same result. And so then you would still have 18 for both of these. And then the main thing is, because it is vertical, you need your y squared first, since the vertical. That's probably a good stopping point. That's 10 questions already. Hope that helps.